Friends, welcome to my YouTube channel. Dhanesh here. So this is the second video on convolutional neural network. Today I am going to discuss about convolution algorithm. Convolution is the first layer of this, convolutional neural network. There are different layers for convolutional neural network. You are familiar with that. We already discussed in the last video convolution layer, ReLU, pooling, fully connected. Once again, convolution layer, ReLU, its activation function, pooling, fully connected. All those layers are in the introduction we discussed. In depth, we are going to first discuss about the convolution layer. Here we are going to discuss about the convolution algorithm. So I am directly getting into this algorithm with some, the math behind this algorithm. So before that, I just want to talk only one thing. See, this algorithm, it is inspired from the visual cortex of human brain. That's really important. The visual cortex of human brain. It's just behind our head, and this visual cortex, it's the neurons inside this visual cortex is sensitive to specific type of edges. Some are fired to the horizontal edges, some are fired to the vertical edges, some are fired to the diagonal edges. These edges are very important in identifying objects. Even there are edge algorithms are there, even Laplace transformation, some advanced mathematics we are using in edge algorithms. So you can, even if you are interested, you can look into that. So these, even here we are discussing some aspects of these edges as well: horizontal, vertical, diagonal, all these aspects. Now when we are reading a letter, see how our normal computer, for example, if I have written 4 here, like this, I can write like this, some will write like this. So in the normal computer, if it is feed with this 4 alone, then the computer cannot read this and this, then it cannot identify it as 4. So how this thing is handled by the convolutional neural network. That's the first point. That's the basis of convolution algorithm. So what it does is very important. It is, see here, in this case, computer take the entire image and compare, but in convolution algorithm it takes small pieces. It takes small pieces or small patches and compare. These small patches, we call it as filters. Very important. Filters or features. This is the difference. It takes small patches and compares. How it compares means it takes a small patch of the input image and it slide it through the entire image and do some mathematical process. Nothing more. It multiply the pixel values in the patch and the image, in the feature or in the filter. Filter is the small patch, in the filter and the image. This is the mathematics behind this convolution algorithm. So I will I will start on this. So first thing is, what are all the different process here? It is, first is, we have to identify the image and the filter. So we have, first I am taking the image. Here we are taking the letter X. So the letter X we are considering. So I have, I am drawing that figure. Just see it. This is our letter X. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So it is shaded. This black. It is shaded with. So I will shade it like this, that it would be easy. It is shaded. This is shaded. This is the X. Then here also. So this will represent X. This is my input image. So here I am, one important point you need to understand, that's really important. Here the white values, the black pixel, actually this is black. See, I haven't shaded fully. Please understand, this is the shaded portion. I am taking it as the black pixel, the very important black pixel. It is +1. White pixel, we are taking it as -1. This is our thumb rule. See, you may be getting doubt. The pixel values ranges from 0 to 255. How this comes from +1 and -1? This is known as min-max normalization. Please read it. That is another type of algorithm. You can use it for min-max normalization or min-max scaling. You can use it and you can change this. So min-max scaling or min-max normalization is the simplest method and consists of rescaling the range of features to the range 0 to 1 or -1 to 1. You can read about that. By that, we changed it to +1 to -1. So this, I am not using 0 to 255 pixel values here. Now, our process, we are going to start. We have identified the object. Now, I am going to identify the features. Features means small pieces of the input image that we call it as the filters. So now my process is identifying the filters. I am going to identify 3 filters, but see, in real-time projects you can identify any number of filters. The more you will get the accuracy. So what is a filter? Filter is a small fragment, small area of your image. That's all. That is a filter. So I am talking about the filter. So here you have 2 things. One is your image and another one is your filter. Filter is a small portion of your input image. We call it as filter or feature. Small piece of an input image, small patch of an input image. That's all, nothing. So it's very easy. Now I am going to identify 3 filters in this algorithm I am going to do, but in your real-time projects you can take 10, 15, 20, any number of filters. The more number of filters, the more accuracy in your identifying the images. Now our 3 filters here, what I am going to identify here, it is the first one. This is the first filter I identified. You can see it here. The second one, I'm going to identify the second one. This is the second one. sorry. Second one, it is it's our filter is having 3 rows and 3 columns. Really sorry, it is having 3 rows and 3 columns. See, we have to again draw it properly. Like this. This was your figure, right? Okay. So our second filter, this is your second filter. Sorry. Now you got the second filter. The first filter in red color, the second one in green color. The third one, I am going to identify the third filter. The third filter is this one. I will take up different color here. It is, this one is your third filter. This is your third. See, it's blue, red, blue. So these 3 patches are our filters. So we are, what is our process? First step is, identify the filter. So I am giving you the idea about one filter. You can repeat the process for other filters. The first filter is in red color, second one in green color, third one in blue color. You understood? The first step we have to follow here is identify the filter. The first filter I am going to use it here is the red one. So we identified the filter. Identify the filter. That's the first step. Second step is place the filter on top of the image. Place the filter on top of the image. Place the filter on top of, we have done it. Third step, we have to do some mathematical calculations after placing on top of that I didn't explain. Fourth step, then we will slide it through. We will move through the image. We move through the image. So the first, you understand the first step, identify the filter, place the filter on top of the image, do some math. After that, again slide it through it. Just, we can move the filter, everywhere, and we can repeat the math. That's what we are going to do. So this thing, the first two steps, you understood. So what is the math we are doing it here? We identify the filter. Our filter is the red one. This we identified, and we place the filter on top of the image. Now the math we are going to do here is we are multiplying the image pixel by corresponding feature pixel. That's what we are going to do. The next step is multiplying the image pixel by corresponding feature pixel. Multiplying the image pixel. So your image pixel here, the black, it is I told you it is +1. So if you are taking your image pixel, you will be getting like this. Your image pixel will be like this. Here your image pixel, it would be like this. Here you have the black, it is +1. Here the black, it is +1. The black, it is +1. All others are -1. This is 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 your image, and your filter is also same. So it's also the same. So you are multiplying with the filter. So the filter is also same. So how you will get it? It is again +1, +1, sorry, +1. Here it is -1. 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 So you are multiplying corresponding cells. See, corresponding pixels. See how you multiply. So you will multiply this with this, this with this, this with this, again this with this, this with this, this with this. So this one should be with this one, this one should be with this one. So this one multiply with this, like this. The next one will be with this. This one will be this. So like this, you are multiplying and adding. This is what you are going to do. When you do this, so you understood, you identify the filter, you put it on the image, then you multiply the corresponding pixels. You multiply the image pixel with the feature pixel. Feature is the small piece of your image. Feature or filter. You multiply the image pixel with the feature pixel or filter pixel. I am using it as filter. That's the correct word. So now I am multiplying it. So when you multiply it, so what you will get? 1 into 1, it would be 1. This 1 into 1, 1. You will get it as 1. Then next, -1 into -1, 1. Then -1 into -1, again 1. Again -1 into -1, 1. 1 into 1, again 1. -1 into -1, 1. Then -1 into -1, 1. Then you can also write it along with me. Then you can draw the pictures and you can write it along with me. Then you will understand this algorithm very well. Then -1 into -1, 1. Then 1 into 1, 1. All are 1. See, you got 1 plus 1 plus. So total, this is 9. This is the next step. So you put the feature on the image. Then, you first step is identify the filter. Second step is put the filter on the image. Then the third step is multiply the image pixel by corresponding feature pixel. We have done it. And the next step is, fourth step is add the map. You have done it. Then the fifth step, what we are going to do here is, now what we are going to do is divide the sum is 9, with the number of pixels in the filter. So how many are the number of pixels? This is our filter. So this is, this is the image into filter. This is what we are doing. So how many filters, how many pixels in the filter? 1 2 3 4 5 6 7 8 9. So total it is 9. We are dividing the sum with this 9. So you multiplied, you added, you got 9. That divide that sum with the number of pixels in the number of pixels in the feature, that is 9 by 9, that is equal to 1. So this is the, once again I am repeating the entire process what I have done. You identify a feature or a filter. So what is a filter? Simple. It's a small portion of an image. Why we are identifying it? Because the entire image, if the computer compares, means it cannot read different images, deformed images it cannot read. One person can X in a proper way or in a deformed way. To identify deformed images only we are using these techniques. So first step, you identified the filter. Then put the second step, put the filter on the image. The red one is our first filter. You can identify any number of filters. Here I identified 3 filters. The second step, put the filter on the image. Then multiply the image pixel with corresponding feature pixel. We multiplied. We got, and sum it. The next step, we got it as 9. And the fourth step, divide the sum with the number of pixels in the filter. How many pixels are there in the filter? 1 2 3 4 5 6 7 8 9. So 9 by 9, 1. You got it. Now you will create a map. This is really important. You need to understand. I am going to explain you now. See, now I am going to create, see, you got 1 as the output from the fourth step, from the previous step. You got 1 as the output. Now I am creating a map. So that map size, if you want to calculate, see, that should be less than the size of the image. It is, the image, you need to understand here. The image size, it is 1 2 3 4 5 6 7. It's a 7 by 7 matrix. It is 7 by 7 matrix. What is the feature size I have taken? It is 1 2 3. Feature, see, image is 7 by 7. It is image. Feature, it is 3 by 3. Then the map size will be, you have a formula. It is the image size, that is 7. If this is, you are taking it as n as 7, and the filter size you are taking it as 3, it is n minus f divided plus 1, n minus f plus 1. This is the formula. This will be the size of the map. You are understanding it? I am I am going to put all these values in a map matrix. See, we are going to put it in a map. What is the size of the map? That's what I am going to tell you. What is your image size? It's 7 by 7. So it is n is 7. What is your filter size? It is 3 by 3. So f is equal to 3. Then n minus f plus 1. That means it is 7 minus 3 plus 1. It is 7 minus 3 plus 1, that is 7 minus 3 is 4, 4 plus 1 is 5. So your map size, we are putting this value, whatever value we got it here, I am going to put it in a map. So this is the value we got it from the first process. So these values we are going to put it in a map. The size of the map is 5 by 5. You got it? So you can padding and stride, that is another topic in convolutional network that you can refer. See, this is a stride means, I will tell you, I am briefly explaining this. So what you understand here is the size of your map is I will come to that point. Size of your map is 5 by 5. So this is your map. Map will be 1 2 3 4 5. 1 2 3 4 5. So this is in this map only. See, here you got the value from the first filter, you got the value as 1. So this 1 you will put it here in this first case. Here you will put 1 here. This is the first entry. Like this. What is padding and stride in CNN? I am going to explain you. Like this, how many times you can, if you are jumping one cell, how many times you can move this filter here. See, next will be like this, second time, next will be like this, third time, next will be like this, fourth time, next will be like this, your red one, like this, next will be like this. So how many times, if you are stride, see, stride means 1 pixel only you are jumping. Even you can change the stride as 2. So how many times you can get it? First time, this is second time, third time, fourth time, fifth time. So that's why I have written 5. See, you got a map of size 5. Even when you go down as well, like this, you can do 5 times. You understood? This is the first one, this is the second one, this is the third one, this is the fourth one, this is the fifth one. 5 times you can jump. Here the stride is 1 because you are jumping 1 pixel. That also you can change. You can change it to 2. Then the output should be different. The map size should be different. So for that only you have used this formula, n minus f plus 1. N is the number of pixels. If it is a 7 by 7, n is equal to 7. F is for the filter. If it is 3 by 3, n is f is 3. That is 7 minus 3. That is 4 plus 1. That's this map. So I am talking about the output of this this map. So I put 1 here. Like this, you can move this filter everywhere. After that you will move it like this. After that you will move it like this. Then you can fill all the values. The same process you can repeat and you can fill this map. So you will get the entire, so you can repeat the same process and you can fill it in this map. You need to understand the size of this map is based on this formula, n minus f plus 1. So move the filter. So this is what you are getting, a map from the first filter. So you will get values here, here, here. The same process you need to repeat. The process is simple. You need to put the feature on the image, multiply image pixel by corresponding feature pixel, add them up, then divide the number of pixels in the feature to the sum. Then you will get a value. So that value you will keep it here, here, everywhere you will get this. You will get a map like this based on this formula. Really important. It is based on this formula. This is for the first filter. So you will get how many maps like this? You will get three maps like this. Again, you will get one more map. For the second filter, you will get another map, and for the third filter also you will get another map. Total, how many maps you will be getting? Three maps you will be getting. It's really important. Three maps you are getting. Three maps. I am raising this like this. You are going to get three maps. For each filter you will get one map like this. For the second filter also you will get another map. You can fill, you can write all these steps and you can come up with your maps. For the third filter also you will get the next map. You will be getting three maps. So this is the process you do in the convolution algorithm. So I have explained, I tried my level best to understand this to make you understand this algorithm very well. So this is the process we follow it. I am repeating the steps once again. Filter. So filter is the key point here. Filter is a small portion of the image. You can identify different filters. Put the feature on the put the filter is also known as feature on the image. Then multiply the image pixel by corresponding feature pixel, add them up, then divide the number of pixels, divide the sum. When you add it, you will get a sum, and divide that sum with the number of pixels in the feature or the filter. Then you put that value in the map. How do you find out the rows and columns in that map? By the formula n minus f plus 1, where n is the size of the image and f is the number of pixels in the filter, and then plus 1. Then you will get the size of the map. If you identify 3 filters, you will get 3 maps. If you identify 10 filters, you will get 10 maps. Excuse me. So like this you can come up with maps. This is the process behind convolution algorithm. Thanks a lot. Thanks for watching.